In this video, we're going to look at how to multiply monomials. I want to start off just by explaining what exactly a monomial is. A monomial looks like 3x squared, where mono means one, and monomial means that there is one term. So the problem 3x squared, it's just one term. There's nothing happening to that one term. It's just a term by itself. What's not a monomial would be something like 4x cubed plus 3x squared. This would be a binomial because instead of one term, there are two, where bi means two, like a bicycle. What I'd like you to know how to do by the end of this video is how to take a monomial, so 3x squared, and multiply it by another monomial. So we'll say 4x cubed. And a problem like this is actually super easy. Our solution is going to be 12x to the 5th power. And if you don't know how I got that, then don't worry, because I'm confident by the end of this that you will. For now, before I tell you all of the rules, I just want you to take a look and see if you can tell what I did to this 3 and the 4 to get to 12, and then what I did to my exponents, the 2 and the 3, in order to get 5. If you can see it, that's great. If not, let me tell you a little bit about the laws of exponents. The laws of exponents say that if I have 2 cubed, and I'm multiplying it by 2 to the 4th power, in order to get my product, all I have to do is add my exponents. So my exponents are 3 and 4. So my solution would be 2 to the 7th power, because 3 plus 4 is 7. If I had 4 to the 10th power times 4 to the 3rd power, my base stays the same, and then all I do is add my exponents. 10 plus 3 is 13. It's the same when my coefficients are variables. So say I have x to the 10th power times x to the 7th power. All I do is add my exponents. So 10 plus 7 is 17. If I had a to the 4th power times a to the 7th power, all I do is add those two exponents. And it's as easy as that. So a problem like this, hopefully already you're like, oh, that's so easy. If we were to take this a step further, we would take our variables, so we'll say a4 and a7 again, and we'll give them coefficients. So we'll say 2 and 3. In order to get our solution, and this is very similar to that very first problem I showed you, all I have to do is multiply my coefficients. So 2 times 3 is 6. And then I use the laws of exponents and say that 4 plus 7 is 11. So I just put a to the 11th power. And that's my solution. Another problem could be 6a squared times 2a cubed. I multiply my coefficients. 6 times 2 is 12. And then I add the exponents. 2 plus 3 is 5. Same thing if my coefficient's negative. So say I have negative 3x to the 4th power times 6x to the 6th power. I multiply negative 3 and 6 to get negative 18, and then I add my exponents to get x to the 10th power. And it's that easy. Say I had negative 2 times y squared, times y squared, times 3y to the 5th power. I would take my coefficients, Negative 2 times 3 is negative 6. Then I would add my exponents. So 2 plus 5 is 7. If you're wondering why this works, we'll take that very last problem and we'll just expand it. So negative 2y squared is negative 2 times y. And then 3y to the 5th power is 3 times 5y's. So that's 1, 2, 3, 4, 5. And then those two things are being multiplied together. We can rearrange this so that our numbers, our negative 2 and 3, are together. And then we just rewrite all of the y's. So that's the first two. And that is the second set. So in order to get our solution, all we have to do is multiply negative 2 times 3 is negative 6. And then for exponents, all it means is how many times we're multiplying something by itself. So we're multiplying y by itself 1, 2, 3, 4, 5, 6, 7 times. So we raise it to the 7th power. Notice that when we expand it, our answer is the exact same as when we use our rules. The beauty of our rules is that it allows us to do much larger problems. So the last example I'm going to give you, we'll do something crazy. We'll say negative 3x to the 4th power times, we'll say negative 9x to the 203rd power. If we were to expand that out, that would be a huge expansion. So we'd have to draw this x 203 times, which is just outrageous. Instead, we can use our rules. So negative 3 times negative 9. A negative times a negative is a positive, and 3 times 9 is 27. And then in order to get our exponent, all we have to do is do 4 plus 203, which is 207. So then we've taken two monomials, so this is a monomial, and this is a monomial, and we've multiplied them together in order to get a single monomial once again. Hopefully, this is now really easy and you're going to have no trouble with it.